Today for the platform game code, I am going to add a custom allocator to the context that Jai passes around to every function. I don't really want there to be any surprise allocations that are allocating from memory pools or locations that I didn't explicitly set up myself. So basically my arena allocators. And then also Jai's temporary storage is fine. So I'm basically just going to make an allocator that asserts false when any operation with it is attempted. I'm going to set that in the context, and then I'm going to compile and run the program and try and clean up all the call sites that are allocating in persistent storage that I don't explicitly control. So let's start by opening up the main file here. So this is in Jai. The Jai beta is still private beta, so I'm not really sure if I can show the content of the how-tos and whatnot. So I'll have this in a separate window. You won't be able to see it, but I will be reading the how-tos to at least understand or brush up on how the context works and what interface I need to implement for an allocator. You'll see the interface, of course. So let me pull that up here. Invoke default allocator. It's going to take an allocator mode, a size, a memory to allocate. Well, the meaning of these parameters vary depending on which mode is being passed. I won't quite explain why this is the way that it is, but basically through this one signature, you can implement a function that knows how to appropriately cast this allocator data to get at its backing storage, which might represent some implementation of a specific allocator, something that I implemented or something that I took from somebody else or something like that. And then behavior is switched on this mode thing. And by calling this one function that knows how to look into a data structure that I specify, I can basically implement a bunch of different behaviors for a single allocator that has one common entry point. That's what the how-to is explaining, one of the benefits of this. So it's a bit heavy, not heavy, but the fact that you repurpose parameters based on mode might feel a bit wonky, but it does provide at least a single point of entry. And most downstream users of the allocator don't actually invoke the allocator function itself. Instead, they'll use library functions like joining strings or creating arrays or something like that, which we'll call new, or some other allocation feature, which will indirectly or maybe directly invoke the default allocator, but indirect from typical call sites. So here, what I'm going to do is simply switch on mode. So if, how does this work in Jai again? Mode equals this, blah, 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 blah. We will return null because we don't anticipate actually doing any work here, but we do need to return some sort of pointer. And I need to go find all the different values for mode, paste them in there. I'm going to do something like this. This is going to be kind of annoying, but we do want to assert false here because we don't actually want to do anything. Attempted allocation with default allocator. Okay, and then we have this feature here complete on the what is Jai's switch essentially, which will force us to handle all cases. Allocator proc is my proc, which would be invoke default allocator, and then allocator data. That's what gets passed in, I believe, as the allocator data pointer there. We don't actually have a particular implementation of an allocator besides whatever's in this function here, so we just pass in null. These are enumerations, so I have to... Now let's try and run it and see what happens. What I expect to happen is if ever I am invoking the default allocator in the context, well, I won't explain too much about what that is, because this is the first video of the stream series, but for those who know, use the default allocator in the context, we should get an assert here, and then I'm just going to go through case by case and try and either use temporary storage or use one of my allocators, or my arenas, I mean, something like that. So let's see now if we run it. And sure enough, something has failed. So let's check out game Jai 59. Indeed, here we have string join. So I haven't done this before, but I do remember that we can update the context on the fly. For those actually who do have access to Jai, I'm reading the how-to 225, Jai file. Let's see. So a shorthand way of making temporary changes to the context. We have already discussed how a primary use of the context is to temporarily swap out a function like an allocator or a logger for a subtree of the program. Typically, you might do something like this, and it shows new context, and we set the allocator, and then we set something else, and then we do a push context. A new context is only the active context when inside the braces of push context block. Right, that's fine, but often you want to do lightweight things and the syntax is pretty heavy. Exactly. Interesting. For example, maybe you want to call join in modules string, but you don't want the result to be allocated on the heap. That's exactly what I'm doing. And indeed, I don't want the result to be allocated on the heap. I want it to be in temporary storage. And in fact, the how-to shows this exact example. Awesome. So apparently, inside the argument list, you can use the comma operator to indicate changes to the context. These changes will only take effect for the lifetime of the call, as though you had pushed the context manually. And they do it by doing this. Let's see, comma, and they say allocator is temp. Let's build it again, then run it again. Build. So we fail again, but now we fail in mapji 67. Okay, so this appears to have used the temporary allocator. I will show real quick. Let's see. Come down here. So we do reset temporary storage here. This is a Jai library call that resets the temporary storage that the context provides. File utilities parse path. Indeed. But let's see what's going on here. This is the tile map path parts, and that should be fine because we never actually store the path in the struct that I am populating. The file read image path name length. This is going to be, well, where do we use path parts, right? Let's see. We use it right here for path to string. Path to string probably also goes to the heap. We'll find out real quick. Path to string, yep, 137 also goes to the heap. Wait, this is incorrect. Path to string is in 103, load tile map 103. But indeed, it goes right to the heap, so all right, and we'll just rinse and repeat this basically. All right, so we've now, all of the primary allocate, or the allocations through the primary allocator are now done on the temporary allocator. I basically make those temporary allocations when I want to construct, as you saw, essentially file paths and things like that, so I can load resources from disk. In this case, I was mostly just loading, in tile sets to build atlas textures, or texture atlases, I should say, from. Now it seems to be running. Just see if we're blowing up RAM at all, if we're leaking or anything like that. Just play around. RAM should be sitting stable because I'm not really loading. After I draw the world and whatnot, I'm not actually loading anything else. And indeed it is. We don't seem to be leaking or anything like that. Not as far as I can tell. Very unscientific way to do this, but I don't see any immediate problems. This is the first time you're seeing this, so you can kind of see I have some random entity here. I might as well explain what's going on. I have collision with the hedges or whatever this is, just a test map to get platform code and algorithms and whatnot working. And then I have a ghost sort of thing spawning here, also collision with it. It has random movement right now. It moves every time I move, and it advances the game state every time I decide to move. We have a move cooldown. Camera follows the player, centered on the player. I'll go ahead and commit that, and then we will pick up the next feature.